All right, so we did proofs yesterday with algebra problems as an introduction to how to write proofs so that when we do them in geometry, we kind of know the ropes, okay? So today, Tuesday and Wednesday, and Thursday pretty much, for the next week, okay, we are gonna focus on writing proofs with what we know in geometry. So we're going to kind of start simple today, and it's going to be kind of a mix of algebra and geometry. Okay? So let's just remember some of the things that we've talked about geometrically. Okay? We know that through any 2 points, there's exactly one line. Okay? We know that if we have three non-collinear points, there is exactly one plane. Backwards, a line contains at least 2 points, and a plane contains at least 3 non-collinear points. Okay? Oh, if 2 points lie in a plane, 2 points lie in a plane, then the entire line is in that plane. Better fix that. Okay. If 2 lines intersect, their intersection is exactly 1 point. If 2 planes intersect, their intersection is a line. Those are things that we talked about in chapter 1. Let's not forget that. Okay? Now, yesterday we talked about properties of equality. We have those same properties for congruence. Okay? So if we are talking about a segment, then the reflexive property would look like this. AB is congruent to AB. Reflexive.
Can I walk down to the office?
No, but thanks for offering. Where do you gotta go?
Kansas, somewhere in Kansas.
Somewhere in Kansas, nice.
They actually played Nigel's team.
All right. Symmetric property of congruence. AB is congruent to AB. No, that's not what I would have read at all. If AB is congruent to CD, then CD is congruent to AB. That's the symmetric property of congruence. Okay? So we can do reflexive, symmetric, and transitive with congruent segments. Okay? Today and Tuesday, so our tomorrow, we are going to focus on proofs that involve segments. Okay? So transitive property segment AM is congruent to segment JC. Oh, but nobody was like, oh yeah, Aaron Misner. That was overlooked, but we got the Josh Kane reference. Okay.
No, AM's the morning.
Oh, and JC is congruent to LG.
Luca Grasso. Oh my gosh.
Then AM is congruent to LG. Thought I picked 3 humans who are pretty similar for the transitive property. You're not good at geometry and athletics and are kind? Okay. Oh, so maybe okay. Should I choose a different person?
Yeah, you can Kale.
Oh, that's so sad. Oh,
No, you do it.
okay. Okay, now. Well, maybe you guys are just like showing me one side of you, huh? All right, let's go through some definitions. So I am not going to lie. The definition of congruence is going to be a popular property for you to use. Definition. Not a property, definition. We will use the definition of congruence quite a bit. Okay? And we can use it one of two ways. Either we're going to say, okay, since AB is congruent to CD, then our next step could say AB equals CD because the definition of congruence. Or we might have AB equals CD, and then with the definition we can say we have two congruent segments. Okay. Now, let's rediscuss the difference between when there's a hat and when there's not a hat. Okay? When there's not a hat for the segment, what are we referring to specifically, Jack? Okay. What is its actual measure? You know how we put the M in front of the angle? Okay? It's like the M for the segment, okay, but we don't write the M, okay? When there's no hat, we're talking about the measure, how long it is, okay? But when we're talking about the hat, we're talking about the segment in general, and the congruent sign is what we use when it has the hat. The equal sign, when we're talking about its numeric measurement, we need the equal sign, no hat. Okay? Okay, so the hats go with the mustache. For you, Aaron. Okay? Now, if we have a midpoint, so like if M is the midpoint of AB, knowing the definition of a midpoint, what could we write knowing that M is the midpoint of AB? Like what does that tell us, Jay? Yes. Okay. Now, I have 3 proofs that I want to go through, and I want you to be a little bit flexible with me. I'm working out of a new book. I'm trying to use as many of their examples as I can. And sometimes I make decisions as I'm typing something up, and then later I reflect and I'm like, I think maybe this would be better. So we're going to make a little bit of an adjustment to one of our proofs. Okay, can you be flexible with me? Okay, so this is what I want you to do. We are going to go to this page right here, example 1, and I want you to, we're going to eliminate option 2, and we are going to, in option 3, make our congruent segments. Okay, and that's how we're going to do example 1. Okay, so as you're making those adjustments, just like yesterday, we always have to start with the given. Okay. Now, let's read through the given. KL, so here's KL, is congruent to LN. And LM is congruent to LN. Interesting. I'm going to use some KL. Oh, is that true? Can we use the transitive property on that bad boy? Okay. We can say, oh, well, KL and LM are congruent to the same segment. So we can use a transitive property right there. Okay. And if KL is congruent to LM, oh, and those 3 points are collinear, right?
Yeah.
Then how do we know that L is the midpoint of KM? Definition of midpoint. Okay. Okay. Now,
Oh, I got this. Oh no.
now we have the other way where we need to figure out the statements. Okay? So, if P is the midpoint of JK, JK,
LOL.
what can we write?
Oh, so you're just kidding, we don't have to do this?
All right. JK, no, JP is congruent to PK because the definition of midpoint. Okay? The definition of congruence would tell us we can go JP equals PK. Okay? Now, why would we need equality instead of congruent?
You have to use these measures of JP and PK.
Ah. Maybe since x is the measure of JP and 5x minus 8 is the measure of PK, we need equality so we can write an equation. Okay? So we are going to substitute the measure of JP with x, and we are going to substitute the measure of PK with 5x minus 8.
Where did we get that?
There's like a picture. Do you guys see the picture?
I've seen the picture.
Okay.
Also, wouldn't it be addition property?
We're not going to add 8 to both sides.
Oh, okay. Then
What are we subtracting?
oh,
5x.
Oh.
And then we can divide. Hey, did we end up with what we were supposed to prove? Well, that's good. Okay. Now, I will tell you something. By the letter of the law, and I think this is more like what our textbook likes, we went from midpoint to congruent to equal.
yeah.
Okay? I would be perfectly happy.
Did you forget the equal thing? Yeah.
Where? Oh, yeah, you have 4x minus 8. Not 4x. Not negative 4x equals negative 8.
I'm sorry.
Oh no.
Is it better now?
Oh,
Okay.
no, you're human and makes it.
Oh no, I'm human. Thank you. Okay. Okay, so back to what I was going to say. P is the midpoint, and then we did congruence, and then we made them equal. Technically, if we know that P is the midpoint, technically, in my opinion, the definition is 2 equal parts. So I would be okay if you went from step 1 to step 3 and didn't do the definition of congruence. Like, I think that you could do this as your second step and do this in 5 steps. Are you picking up what I'm putting down here? Lydia, did you say no?
Wait, why? I don't get it.
Okay, so what I'm saying is it would be okay for you not to do this step and just go, okay, if P is the midpoint, I have two equal segments. Yeah. Okay. All right, so let's maybe try this one. Okay, so it looks like my last step needs to be y equals 8. Okay, I have two congruent segments. If my last step is y equals 8, what does my second step need to be? Definition of congruent. JK equals KL. So I can say, okay, definition of, you know what? Don't feel like writing that word. Gonna draw the symbol. I'm feeling a little lazy on Friday. All right, now what is the measure of JK? 15. The measure of KL is 3y minus 9. That is the substitution property. Okay. What shall we do next?
Add the 9.
Let's add the 9. Ooh. And we get what, 24? Ooh, I'm excited about this one. Okay. Our next property is going to be the division property, correct? Because now, 8 equals y. I'm done?
No.
Our last reason, symmetric.
Oh.
Symmetry, would that be wrong?
Okay, if you said symmetry, I'm probably not going to